Okay. And let me also announce that there is going to be a reception afterwards. So this is in this kind of very formal webinar format where we can't see each other very well. But afterwards, we will have a reception. And I think Loretta is going to put into the chat, she has the link to join us in the reception after the talk and the Q&A. All right. So it is my distinct pleasure to introduce Professor Alicia Beckford Wassink, who will be presenting the Department of Linguistics 2021 Martin Luther King Jr. Colloquium. It's always a special honor to introduce our MLK speaker, but especially so when that speaker is an alumna of our department. So Professor Wassink is on the faculty at the University of Washington. She specializes in sociolinguistics, phonetics, and Creole linguistics, and often works at the intersection of these three areas. She's well known for her distinguished work on the sociolinguistic and especially sociophonetic patterns of Jamaican Creole, African American language, and on the English spoken in the Pacific Northwest, where she has lived for more than 20 years now. Her work, much of which is funded by NSF, addresses important and difficult issues surrounding language accommodation, language ideology, and how children acquire sociolinguistic competence in the variety or varieties that they are learning. She's also known for her public scholarship on these topics. In her most recent work, which I know I'm excited to be hearing about today, and I know many of you others in the audience are as well, she has turned to issues of linguistic discrimination and racial bias as they relate not only to what human interlocutors are doing in their speech interactions, but also to the field of human-computer interaction. So our department's choice of our Martin Luther King speaker is always a significant one. But that is perhaps especially the case in a year such as this one, a year that has been shaped by the struggle for civil rights and social justice and against anti-Black racism. So in celebration of the life and accomplishments of Dr. Martin Luther King, I ask that you join me in welcoming Professor Wassink, who will be speaking today on uneven success, racial bias in automatic speech recognition. Welcome, Alicia.
Thank you so much, Pam. It is a real pleasure to be with you all, and I'm hoping that you're able to see my first screen. Is that appearing properly for people?
It's not on yet, Alicia. It says you've started screen sharing, but we're not seeing you quite yet.
Okay, let me see if there's something I needed to do differently. I'm going to stop my share here and see if I can try it again. And is that working?
Not yet. We saw it before.
Yes, we had it before. Is there another screen share that needs to be disabled?
Loretta, Will, any ideas on your end?
I'm not sure. We didn't change anything.
Okay, yeah, neither did I. Okay, let me try. It says that I'm screen sharing.
I mean, what I'm seeing is Alicia was, it gives your name, you have started screen sharing and you need to double click to enter full screen mode, but I think, I'm not sure.
That's what I saw as well.
Yeah.
That's what you see as well. Okay, because I'm able to actually see both my screen and my presenter notes. So
it may also take a few seconds for your screen to load besides the double click. So maybe you should try again.
How about this?
There we go.
Okay, perfect.
All right.
All right. Do let me know if there are further problems, but I'll get going. So thank you for inviting me. It really is like coming home, except
All right, Alicia, I'm sorry. Now I'm going to have, so now we're seeing, in addition, I don't know if everybody else is seeing this, covering up the upper left portion of your slide.
Is my Zoom window?
There we go. Okay.
Okay.
You're good to go.
All right, everyone. So I would love to be in beautiful Ann Arbor with you, but the circumstances don't allow that. So I'm happy to be with you remotely. All right, so today I want to give you a higher level talk for the holiday, but in it, I want to share some thoughts about bias in linguistics that are supported by original research I've been conducting to flesh out what inequity might look like in automatic speech recognition. This project that I want to talk about kind of began as a means to an end, but has become a major focus of my research. So in my lab at the UW, University of Washington, we use ASR to facilitate acoustic study of Pacific Northwest English. And what we're doing is using it for analysis of data from a multi-ethnic sample of Washingtonians, including the Yakima, on whose land I have been privileged to be able to work for several years now, including also African American Chicano and Chicana speakers. And what we are looking at in part is the way that Washington English reflects the state's history of interethnic contact. What I'm going to do is talk about the aims of this kind of ancillary ASR study, and I'll give some necessary background covering what I mean when I say racial bias in linguistics. And I'm going to give a little bit of a primer on ASR. Then I want to talk about the research study itself. I want to focus on a custom-built ASR tool called Clocks that we've been developing in my lab. That's the basis for this research. And I want to focus on the way that my research centers on leveraging the notion of the sociolinguistic variable. In the results section, I'm going to talk about the ASR errors that I've been finding by ethnic group. And then we'll talk a little bit about some surprising findings, perhaps if there's time, and some conclusions. So I need to add that since September, I've been working on a large-scale project with a prominent technology company in my region. My NDA, though, prevents me from saying who, but the project's aims are to try to improve ASR in Black and African American communities. So I need to add that the work I'm presenting on today is my own. It's not work that I'm doing as part of that collaboration, although it does inform it. Okay, so before going any further, I need to give credit to two great teams that have contributed to this project. My Clocks team on the left has worked with me on developing our ASR tool and doing the Clocks error analysis that I'm reporting today. And my Pacific Northwest English team has been involved in field data collection and linguistic analysis. This research is also supported by a grant from the National Science Foundation. Now, it would be wrong for me not to celebrate and acknowledge the Reverend Dr. Martin Luther King Jr. as I start. MLK gave an annual report of his work in the civil rights movement shortly after the inauguration of John F. Kennedy on January 20th, 1961. This was published under the title Equality Now, The President Has the Power. King said, "The new administration has the opportunity to be the first in 100 years of American history to adopt a radically new approach to the question of civil rights. It must begin, however, with the firm conviction that the principle is no longer in doubt. The day is past for tolerating vicious and inhuman opposition on a subject that determines the lives of 20 million Americans. We must decide that in a new era, there must be a new thinking. If we fail to make this positive decision, an awakening world will conclude that we have become a fossil nation, morally and politically, and no floods of refrigerators, automobiles, or color television sets will rejuvenate our image." Prophetic, I think. I grew up with a grandfather figure, the Reverend Ernest Wilson, pictured here, who was also active in the U.S. civil rights movement. In fact, he had the opportunity to preach alongside Dr. King in 1967. So I grew up kind of steeped in my grandfather's admiration of this man, including hearing speeches that didn't come to be the most famous ones. So this one has really been on my mind. Aside from the fact that it was given after an inauguration had taken place, which I think in of itself is really timely for us, As I work on a project centered on a new technology, I'm noticing that King referenced the then forward-looking US exported technologies. And, I can substitute words like computers or voice assistants for his refrigerators, color television sets, and think about the fact that there's no technological advancement that can address inequity without leaders' will. So I'm focusing on that as part of my work. Now, not all sociolinguists use ASR. As I said, I turn to it as a kind of side project. It is meant to aid in the transcription of the very large amounts of conversational data that my project was generating. In some cases, we have 2 hours of recordings for about 120 of our speakers. So we found ourselves, as many sociolinguists and phoneticians do, correcting the transcriptions that it seemed like at times we were better off manually transcribing because the ASR was failing for some of our speakers. So in the process, I noticed that not all features of pronunciation in the sample were handled equally well. I realized this is a problem not just for my research, but because contemporary consumers rely increasingly on virtual assistants, like, Apple's Siri, Amazon's Alexa, Microsoft's Cortana, which take voice queries and use artificial intelligence to answer questions or make recommendations, perform actions like web search, even control lighting in our homes. And there are a lot of people who use these for utility bill payment or credit card payments. A friend of mine tried to use OnStar, which can, from your car, contact emergency medical aid if you're in an accident, but it can't handle his Georgia African American English variety well. So this means that there's inequity in access to services. And it turns out that knowledge regarding sociolinguistic variation has yet to be exploited really in acoustic model architectures. So for me, there's a personal as well as a professional significance to this work. It's an area in which I think I have a chance to pursue inequity as a sociophonetician. So using original data, I'm going to be asking the following research questions. First, is there a difference in error rates for my 4 ethnicity-related subsamples? If so, what differences do we observe in those error rates? What is the by ethnicity distribution of these? And second, what dialect features appear to be most challenging for my clock's speech-to-text service, which is Microsoft-based? Are these dialect features more typically found in the more casual speech tasks? So moving on, I want to tell you what I mean when I say racial bias. It's a form of implicit as compared to explicit bias, where we're talking about automatic associations or stereotypes made by individuals in an unconscious state of mind. So whereas explicit bias can show up as overt racism, name calling, being told you're not getting a job because of your race, implicit bias occurs unconsciously, typically without discriminatory intent. Our associations, though, influence behaviors, and the National Initiative for Building Community and Trust says, quote, making people respond in biased ways, even when they're not explicitly prejudiced. So bias shows up even where implicit associations we hold don't necessarily align with our declared beliefs or reflect stances that we would explicitly endorse. But we can also define bias at an organizational level, and in this I include scholarly disciplines like our own. It can include unequal access to the beneficial work of our organization, or to racial disparities in the structure of our organization's roles and offices. For me, it's important to note that it can mean systematic inclusion and exclusion in how the work proceeds, or in failure to examine disparities with intent to identify, address, or reverse underlying causes. So this definition says that there can be bias where we learn of disparities but fail to address them. Hutton, 1999, explores 19th century linguistic scholarship and finds that language was a key part of the master narrative of cultural description. Language, for both philologists and anthropologists, was a major determining factor of culture, and culture was often equated with race. Hutton says that the idea of a common genealogy was preceded by that of a common language. So linguistic categories were used to elaborate a set of cultural categories for mankind, or humankind. And we found that there was, because of the elevation and hegemonic positioning of some languages, like German, in philological research, scholars became focused on the study of pure forms of languages, as if languages were monolithic, which we know they're not. So this wasn't intended by us, but it was part of the inheritance of modern linguistics. Hutton argues that out of this came an emphasis on North American generative linguistics, on a monolingual ideal, the Chomskyan notion of the ideal speaker-hearer who speaks their language perfectly and speaks without disfluencies, speech errors, etc. Of course, this idea was and still is that the abstraction can be beneficial because it helps to focus and simplify our object for study. But how often do we think of who or what we're leaving out? And I will note that sociolinguists are not exempt from this. We've been guilty too, particularly within first wave socio. The taxonomic view was privileged in urban dialectology, which sought out non-mobile, older rural males for study. And of course, in Lebovian sociolinguistics, we often focus just on majority ethnic communities for locating regional norms. Right? And determination of community membership can be based not on how people identify themselves, but on the researchers' sampling procedures. So I think linguists still have a tendency to associate race with language variety, as in studies of African American English or Chicano English, etc., where we use gross social notions of social and ethnic categories to determine how a language variety is characterized and who's a typical member of the community. I also think that we have to acknowledge that alongside racial bias, we have a tradition of inherited colonial bias in linguistics. The UC Riverside linguist Wesley Leonard, who's also a member of the Miami tribe of Oklahoma, has found that as a native scholar, it's expected that he work on language endangerment or language shift, documentation, or revitalization. In general, though, his work challenges linguist notions about dying languages, including who gets to be counted as a native speaker. His community's mode of language transmission calls into question what it means to be a native speaker of a language, because the Miami emphasized learning a language through archival records. The community accepts this type of learning as sufficient for knowing a language, but this isn't the generational cultural transmission model most linguists use and approve of. So his work is broader than endangered language study. He focuses on advancing decolonized conceptualizations of the native speaker and speech community that center local communities' understandings, like the importance of return to a heritage language. So this is not racial bias in this case, but it points out ways that linguists look at language through a colonial lens. There's sort of a large cultural box, I'd say, for American English that privileges white speakers for study, while other speakers are kind of held aside from that big box in smaller boxes to be attended to later, and are often associated with expectations maybe that because of who they are, they speak a sociolect. This is important for the Pacific Northwest English study, where Yakima English is included, importantly, because I think it allows us to depart from the dictum to hold certain speakers aside until after that primary work is done. This is something I actually feel strongly about because in the first National Science Foundation proposal that I made to study the dialect of the region, I was told to hold non-white groups aside until the white population study was done. I think that it's also important that we apply more sophisticated notions of sociolectal features, including transfer from heritage language and notions of what Jackie Rahman calls linguistic diplomacy, that allow us to study the full range of an ethno-linguistic repertoire, including participation in local, regional, in my case, Pacific Northwest forms. So for me, bias isn't just about inclusion of equity-related goals for African American communities, although it includes that, but also for other groups that have been excluded as well. My own work is just a part, I would say, of new emerging emphases bringing together sociolinguistics and voice technologies. A study contemporaneous with mine was conducted in 2019 at Stanford by Alison Konecki and her colleagues. They looked at racial disparities in 5 commercial speech-to-text tools, Amazon, Apple, Google, IBM, and Microsoft. And they used these to generate transcriptions for African American English speech from 3 different locations. They examined word recognition in sentences with AAE syntax, focusing on constructions like copula deletion in he a pastor. Part of their experiment was investigating what's called perplexity. Perplexity is a standard performance metric for language models in ASR systems, which is calculated the number of reasonable continuations of a phrase under that ASR model. So given a sentence like the dog, or a phrase like the dog jumped over the blank, there might be several options for ending the phrase. In this example, if there are 3 such possible continuations, like fence or box or stick, perplexity would be 3. The better the language model, the lower the perplexity. So they compared the average perplexity for their African American English sentences against a control set produced by general American English speakers as controls. What they found was, surprisingly to me, that in fact the perplexity for their African American speakers was lower than for their white speakers. So even though the ASR systems on average found this, they were more likely to get words wrong for the AAL speakers, as evidenced in higher word error rates. They concluded that it wasn't the language model that was prone to bias. They said that the results must be due to phonetic factors, although they didn't actually test any of these. So this work was not actually in print at the time that my research began, but I see these findings as really highlighting the need for the research that we're doing, because we are now getting some phonetic error rate data. So I mentioned a minute ago the notion of a language model. What is that? I want to talk a little bit about the typical architecture of a speech recognition system. So I want to preface this by saying that my team and I are trying to learn how the ASR architecture works for the system we're testing, but it's a little bit of a black box. Big tech companies make only some of the information about their systems publicly available because they're proprietary. But the architecture is probably something like what you have here on the screen. Has 2 kind of fundamental components, a language model and an acoustic model. So starting with an audio clip like this one here for a phrase like grande hazelnut latte, one of my favorite drinks, we chunk the signal into windows of 25 milliseconds in duration, spacing these about 10 milliseconds apart, and we extract Mel frequency cepstral coefficient features, giving us a sequence of time-indexed vectors that represent the frequency spectrum at each time x. These 39 MFCC parameters are extracted from each 10 millisecond frame, giving us a time-dependent phone like T. Each time-dependent phone has an associated acoustic model that specifies what its spectral features might be after a preceding segment or preceding another one, each with its own associated probability. Candidate acoustic models are selected based on a pronunciation model that gives tables in which words have been converted into their component phones, as you can see in the broad phonetic transcription above. So these pronunciation models might have a little contextual information that specifies, for example, that a word final T is likely to be inaudibly released, but released in a syllable onset, like in latte. The language model specifies the likelihood of a word sequence given previous material. So grande hazelnut latte is more likely than latte grande hazelnut, unless you're not good at offering coffee drinks or ordering them. So the language model is what predicts the next word given previous words. Now, what I've learned is that there's not a lot of sociolinguistic information included in pronunciation models. So I can ask, can we leverage sociophonetic knowledge to improve the pronunciation and acoustic models used by ASR systems? With that, I'm going to turn to the study. We use 16 speakers for this small project from 4 different ethnic groups: the Yakima, a Mexican-American subsample, African-American, and Caucasian-American. As a disclaimer, in my lab, one of our anti-racist practices is to avoid analyst categories by trying to apply a more expansive definition of speech community membership that relies on first speakers' own self-identifications, and then social network data, including their membership by virtue of their contacts in the speech community, and finally, the length of time that they have been in the speech community and how rooted they feel in it. So in this context, we have about 45 to 90 minutes of speech per recording, for a minimum of about 20 minutes of speech per talker, yielding about 9,000 to 22,000 words per ethnic group. And this corpus is about 13 hours of data. We are gathering data from across Washington state for this. Our Caucasian speakers are from the Metro Seattle area. Our Chicanic speakers are from South Central Washington in the Columbia River Valley. Our African American speakers come from Eastern Washington and Spokane. And our Yakima Nation speakers come from around the town of Toppenish in South Central Washington. And these colors are going to show up again when I talk about the error results, so it might help you to orient yourself to these results. So for the tasks that we ask of each speaker, one difficulty sometimes described in the computational linguistics literature with respect to developing adequate training corpora for speech recognition systems is the unmet desideratum of acquiring comparable data for all speakers in a corpus. I think that one advantage of utilizing the PNWE corpus is that sociolinguistic study design follows a disciplinary convention of using a multi-part interview that includes some scripted and some unscripted tasks. So we use material from 3 tasks to assess ASR performance. Free-flowing conversational speech, where we have a casual style produced with a peer, for which we have a set of common topics based on a common interview guide called the Question Generator, or QGen2. This yielded uneven amounts of speech, about 500 to about 6,000 words. Second, we have a series of lexical tasks or word games. These are semi-casual tasks conducted with single individuals, including lists like the numbers from 1 to 10, days of the week, etc. We also have minimal pairs like dawn, dawn, guard, guard, and semantic differentials, where we ask questions like, what's the difference in meaning between a sack and a bag? So these are only partly controlled because although there are fixed turn taking behaviors, there's also unscripted talk while the task is being completed. And this has yielded a little bit more consistent data between speakers, between about 200 and 600 words. Then finally, we use reading passage data, which is fully fixed. It's a citation style of speech that always yields the same 342 words for all speakers. And crucially, in all of this, we have a set of 17 common sociolinguistic variables that we can look at for each speaker. I'll itemize these in a moment, but what this means is that we can compare error profiles of the ASR system across different tasks that vary in register. So for the error analysis, we take output from a custom-built automated audio transcription service called Clocks that we've been developing over the last few years in my laboratory and is freely available for any of you to use. It's built on the Microsoft Developer Library offered by Microsoft Cognitive Services Speech Division and uses their speech-to-text software development kit, or SDK. Clocks delivers a conversational recording to Microsoft servers, which then returns a plain text transcribed output. Then Clocks performs output checking and gives us back timestamps, including the start and end time of each run of speech. So to show you what this looks like in action, I have a little video of Clocks working. So while the transcription takes place, output appears in the results box at the bottom of the screen, and you can watch out for the non-word ACMA, ACMA, which actually means Yakima. So you'll see that this prose is advancing, and while the transcription takes place, you'll notice that it supplies changes made by the language model as Clocks runs. It makes upstream changes, meaning that words are able to be changed retroactively after new words are figured out by the language model. You can also see that punctuation and capitalization are added as the engine figures out sentence boundaries. Okay, so that is the intersection between the acoustic model, the pronunciation model, and the language model at work. So all of our recordings were submitted to Clocks in this way. The transcripts that Clocks returned were manually coded for errors. We listened to these each by hand using Elan software and entered the output into an Excel database that lists the erroneous token in one column, our manual corrections in another, and then we were able to class these into sociolinguistic variable types. Inter-rater reliability was checked over 20% of each file, and agreements were entered into the finalized documents. We used our software for numerical analysis and our inferential statistics. The dependent variable for our analyses is phonetic error rate, or PER, which was computed as the proportion of all coded errors that fall into a particular error class. To enable comparison across corpora of different sizes, this is necessary. We needed to normalize our frequencies to represent the relative frequency of errors in our corpus. That is, as we represent errors as a proportion of the total word count for the corpus, we multiply that by a base of normalization of 100 words that enables us to say how often might we see an error per some number, in this case 100 words, of running text. Okay, so we have a worked example at the bottom that says that for this sample we got 4 errors per 100 words of running text. So I want to just very briefly go through the error types that we classed all of our recordings into. I want to show these with actual examples of errors from the Clocks corpus. So the first type were general errors that are not associated with any specific dialect, but are potentially attributable to common connected speech processes in English, or forms that the system was not able to classify because they were proper names. So these are not associated with a particular sociolect and not typically targeted for sociophonetic study. These are things like reductions, where clocks returned lotta for the target lot of, or proper names that were mistaken, like the place name Toppenish, which clocks told us was topless. More important for our study are the sociolinguistic variables we targeted. There were 17 of these, and for this, we relied on earlier published reports of findings from the PNWE study, some by me, some by my colleague Sharon Hargis and I. And so I'm just going to look at a few of these that are important for our sociolectal study. One of these was unstressed ing, in progressives in particular, which is important for Yakima English, but other varieties as well. TH stopping was also important for our work. And it turns out word medial glottalization and glottal replacement of forms like write-r for the target writer were also important for this research. We also targeted things like lenition, because that's important for the Chicano English subsample. So it might well be asked, these ethnic groups use potentially different sociolects, so why look at a common set of variables? I think there are 4 good reasons for this. First, as part of the larger study, we wanted to know whether regional Pacific Northwest changes present a problem for the ASR system. Second, we do know that some forms actually span non-standard dialects of English. We want to be able to see to what extent they span the ethnicities in our sample. Third, it may be that certain errors are in fact particular to certain sociolects, and so this doesn't prevent us from finding that there are certain variables that do indeed turn out to be particularly important for particular underrepresented groups. And then finally, if we see certain common errors are observed for multiple groups, this means including sociolinguistic knowledge will represent greater gains for ASR. Okay, so in addition to those 6 consonantal variables, we included 10 vocalic ones. And again, I'll just hit some of the most important ones. Obviously, perhaps the cot-cot merger, which has been widely described for the US West, is an important pattern to include. But more close to home, voiced prevelar raising of ag and egg in words like bag and beg is also important. And you can see here that there were some errors that were tested for those particular targets. Also important in the West is prelateral merger of the high and mid-back vowels, and pin-pen merger, important for African American varieties. So these are associated with specific dialects, and they are targeted for sociophonetic study. All right, so quickly on to the results slides. I'm going to present a few graphs like this one that collect together on the y-axis the linguistic variables that we just saw. We have vowel errors and general errors. So general errors in the green at the top of the graph. Our vocalic errors are just below, and then our consonant errors are below that. So as we move between groups, we can observe an increase in either the number or the length of the green bars in this area here at the bottom that represent new types of errors that are giving the system trouble. And then we have a table at the bottom that just breaks out the percentages of each error type that constitute the total error profile for this sociolect. Overall, we can summarize the differences between groups in phonetic error rates. In response to the first question about whether there is a difference in error rate between our 4 groups, the answer is yes. You can see that we had about 1.5 word errors or phonetic errors per 100 words of running text for the Caucasian American sample, about twice that for the African American sample, and 4 times that for the Yakima and Chicanx speakers. This result was significant in a one-way analysis of variance, and subsequent Tukey's pairwise contrasts revealed 2 significant pairwise differences between the Yakima and Caucasian groups and between the Chicanx and Caucasian pairings. So looking at the Caucasian sample, I found it really interesting that there were very few errors. If we just focus on this area down here, we see that the only sociolectal error was associated with the bag phenomenon. In fact, 82% of all of the errors were of the general type, and these included homophone errors, so wheres and worse being confused for each other when they were both pronounced phonetically as worse. Forms like word medial flapping of T or D, and other vowel errors like being mistaken for will. For the African American subsample, we actually add 9 new error types. Again, the majority of all errors were of the general type, but 14% were dialect specific. And within this set, we see now, interestingly, vowel errors, pin-pen merger errors, a hallmark of African American varieties. But we also see prelateral errors like Tyler Powell being mistaken for taller dollar, and caught errors, which gave clocks more trouble for our African American speakers than for the European American group. Moving to the Yakima subsample, to the 9 that we just saw, we add an additional 2 consonant error types. One was a vowel lowering error type, like in the case where medicine was mistakenly returned as Madison. As expected, TH stopping was a problem, so pen them was mistaken for the nonsense word pendum, and in progressive verbs was commonly mistaken as well. So dig in, mistaken for dig in. For our Chicano and Chicana speakers, we add on top of those errors 2 more. We expected to see lenition, and in fact, we did see lenition-related errors. So for cheat, clocks returned sheet. And when a speaker said kitten, clocks returned akin. We also see prevelar raising errors, as well as pin-pen merger errors for this group and others. So finally, turning to our last research question, what dialect features appear to be most challenging for clocks? And relatedly, are these dialect features more typically found in the casual speech tasks? So to actually answer the second question first, of the total of 3,167 errors, the majority, or 70%, were indeed in the unscripted conversational tasks. Interestingly, only 22% occurred in the lexical tasks and 8% in the reading passage. I think that the results for the lexical task were surprising to us. This is because the conversation and reading passage tasks were expected to actually benefit from the dialogue-based language modeling algorithms, which take advantage of conversation level consistency, given that conversations nominally follow topics, whereas our lexical tasks, on the other hand, comprise short sort of interview style question and response sequences that only span about 2 to 3 utterances. So we were surprised that, contrary to our expectations, error rates for the lexical task materials were pretty low. Then, at this point, I can return to ask which of our variables were most problematic for the ASR system. This facet plot shows our sociolinguistic variables by ethnicity and task. I realize that it's busy, but I'll break it down here. It has 3 panels, one for each task: the casual speech at the top, the lexical tasks in the middle, and the reading passage task at the bottom. The columns are our ethnic groupings, from African American to Caucasian American, Mexican American, and Yakima on the right. The height of each bar represents the proportion of phonetic errors for each sociolinguistic variable within a task, then within each ethnicity group. So we are just looking here at the sociolinguistic variables. I've taken out the general error types. So the proportions won't add up to 1 because the general types are not shown here. So looking at the bar heights within an ethnicity, we can focus just on the tallest bars. So first, TH stopping was really important. Erroneous transcriptions of words containing TH stopping were most frequent for the Yakima recordings across all tasks, but mainly in the conversational speech like we expected. So it's certainly a prominent feature of this sociolect, but we also see that it was a problem in the case of a couple of the other groups as well, though much less so. The caught merger was also very interesting. So in the West, as you know, or may know, we understand that the merger is pretty advanced. So I thought it was interesting that the most problematic ethnicities for this particular variable were not the merged Caucasian American materials, but the 3 non-white ethnicities that are not participating as much in the merger of caught and caught. So I'm in the process now of looking into the pronunciation tables to see what might explain this finding. Finally, consonant cluster simplifications. We found erroneous transcriptions occurred for singleton codas, particularly in the Mexican and Caucasian American subsamples the most. Here, about 15% of the errors in the casual speech task for our Caucasian speakers and 12% in the reading passage. And that number rises in the Mexican American materials to about 26% in the conversational materials. And there are other taller bars that we can look at too, but those were the most important ones. Right, so to conclude then, this research has tried to accomplish, as a start, a cross-ethnicity comparison of dialect-based ASR performance. We feel like this is important because it's, as far as we know, the only study that has quantified the contribution of a set of general as well as ethnically related linguistic variables to the phonetic error profile of an ASR system. We think it's worth it because, by our estimations, it could eliminate about 26% of observed errors. And we think it's further important for sociophoneticians because, like I said, the ASR was really just a useful tool on the way to actual linguistic analysis and sped up, or could speed up if it improves, our actual phonetic analysis. So for the PNWE study, to kind of take on the question that I understood to be your theme for the MLK Day talk, where do we go in the PNWE study team from here? Well, we continue to try to improve access for all people to services that rely increasingly on ASR. And we're continuing to collaborate with industry and to also advocate for leveraging sociolinguistic knowledge of the fine phonetic detail in dialect variation. I'm happy to say more about how we're doing this in the Q&A if there's interest. We're also working on actually implementing a new pronunciation model that brings in about 15 of our targeted sociolinguistic variables to an ASR service that gets us out of the black box, but uses the freely available architecture for ASR provided by Caldi. And what about linguists more generally? Well, some ideas about where we go from here include the following. First, in sociolinguistic studies of sociolectal variation, I think we need to move ahead with continuing to work on variation, right, in AAE as well as other sociolects, not treating these as monolithic. I think we also need to continue to develop methods for study of multilectal speech. And finally, I think that it's been profitable for my research to use a more expansive notion of what constitutes a native speaker. But outside of sociolinguistics more generally, I think that linguists have a role to play in undoing racial and colonial bias. I think that we have a role to play in looking out for the overlooked. I think this may be, I was exposed to it as an African American folk saying, it might be more general than that, but Kamala Harris has recently repopularized this phrase in her recent memoir, The Truths We Hold. We can work on asking who gets excluded from our linguistic research and trying to reverse the causes of exclusion. And finally, organizationally, we can continue to work on improving the representation that we have in important roles, in employment, in tenure, and promotion. So those are just some ideas of where we can go from here. And with that, I thank you for giving me this opportunity to share some research with you. And if you are interested, we are running a perception test in my lab right now that can get you involved in the research that I've just been talking about. So I invite you to check out those links. There's also a link here for clocks if you'd like to try it out. Thank you.
Thank you so much, Alicia. That was a perfect talk in all respects, and especially as an MLK talk. So thank you so much. Let me remind people. So Alicia has graciously agreed to field questions, and they're already starting. So let me remind people, I see there are a few in the Q&A. The preference is that you raise your hand. I will take the ones that are in the Q&A as well, but from now on, if you could raise your hand, that would be great. I'm going to cheat. So because although there are other questions already asked, Alicia, I just wanted to start you off with, I really loved that you ended with a plug for getting some speech perception experiments. That's like a true phonetician, what can I say? So I'm curious about the result, the finding that consonant cluster reduction gave you more errors for the Caucasian Americans than for the African American speech samples that you had. And I mean, have you gone and is it too early to have looked at the acoustics of those to know, did you in fact get more consonant cluster reduction for the Caucasian Americans than for the African Americans, or it just somehow didn't do as well?
Yeah, I think that's a really interesting question. Yes, we have gone in and started to look at the acoustics of that. And it does appear that there were more types of consonant clusters simplified by the Caucasian American speakers than the African American speakers. So one of the things that I am hypothesizing right now is that some of the like low-hanging fruit types of consonant cluster simplification that we might expect, like ST clusters for some reason, are not handled as well, which surprised me a little bit. We are kind of working right now on trying to describe what the types of clusters were right now. And initially we were just sort of saying, was it a consonant cluster that was mistaken? But we didn't actually break that down to see what places of articulation and what types of clusters they were. So I was surprised, for example, because in AE, for example, LD clusters are famously simplified, right? So where it's like rolled for roll. And that didn't turn out to be as much of a problem as I expected that it would be. So we're looking to see what types of clusters were actually implicated in this. I want to also say that one of the things I think might be going on is that in the Pacific Northwest, we don't see for the AAL speakers as kind of showcase features of AAL as you might in other regions. And so I don't want to say that they're sort of less basilectal, but I think that at some level they may actually be different than the types of phenomena that we would see for AL speakers of other regions. So as I kind of grow this work that I'm doing with the tech company, one of the things that we want to do is look at other varieties of AL as well and see whether these results look different.
Yeah, that's exactly what I was wondering, is if it was that particular variety of AAL. So thank you very much. And now I'm got to stop being selfish and start answering some of, there are questions and a lot of raised hands and also questions in the Q&A. So let me just, I'll take at least the first one from the Q&A. Reed Blaylock, also a former alumnus, in this case from our undergraduate program. Hi, Reed. Says, thanks for a great talk. What was the reason for using single phones such as T rather than diphones or triphones in the acoustic model?
Okay, so with regard to clocks, I just want to be super clear that that was not a choice that we made. That we're working with the acoustic model that is in the Microsoft ASR system, and we're just implementing it. So as far as we know, they use a bigram model at the language model level, and a single phone model is what I've seen described in the white papers that we have access to for the acoustic model, although I'm told that they do include contextual information. So that's where the black box issue comes in. I can't say much more about what's actually in the acoustic model, although I'm trying hard to find out.
I see Reed just put in the chat, fair enough, thank you. Okay, Ben Lehman had a question asking, so I had noticed this as well, you had 16 people listed. This is a small, quick little, just, you know, point of information question. 16 people were listed in the study, but we only counted 15. And we were wondering, was there somebody else in a different category? Or maybe there were only actually 15 participants.
Oh, in the breakdown by gender that I gave on the method slide?
So, I mean, so there were 5 Yakima, 2 or Yakima, 3 Mexican American, 3 African American, 4 Caucasian American. What I had is what we had.
Yeah, thank you for noticing that. Very good.
All right.
I
Okay.
remember from my thesis that Pam was always adding numbers and I always needed to be able to explain myself. So I can explain this. We actually thought that we did not have consent from one of our Yakima speakers, and so I initially did not include him. He was one of the elders of the community, and I wanted to be very careful not to use his data without his permission. But I did end up getting permission to use his materials, and they're included, and I did not update the numbers. So that's the reason why.
Thank you. All right, the last one from the Q&A, and then we'll be turning to all the raised hands that are out there. Okay, so this is from Patrice Johnson. Thank you for this presentation. Please say more about what is included in industry collaboration and the potential impact of studies like these on the business world.
Yeah, that's a really great point. It's a great question. I think that one of the things that I can say, I'm trying to make sure here that I don't violate my NDA. So I initially presented a version of this research at the American Academy of Science meeting in February of 2019. And the tech company reached out to me because they recognize that sociolinguistic variation is not incorporated in their materials and in the ASR architecture more broadly. Part of what I have discovered is that when we're talking about non-white ethnic groups, there is a tendency to treat sociolectal features as if they're just reductions. So one of the things that I discovered is that there was a great interest in just explaining what sociolinguists understand about non-white ethnic groups' local sociolects. And so talking about things like language transfer from a heritage language in the case of the Yakima, talking about things that are not reductions, but are in fact part of the grammar for AAL. So for example, I've given talks about remote time bin and the other types of tense aspect features of AAL that are not reductions, even though we don't see an express form of to be, that's not a reduction, right? So just those kinds of things are really important for linguists to be able to engage computer scientists and less so computational linguists. But there's also lack of knowledge about how sociophonetic variation is not phonetically continuous. So when we talk about glottal replacement of T, for example, you can't get, by tweaking MFCC features, from an unreleased T to a glottal stop. You actually need information like creak on the preceding vowel. You need information about duration of consonantal closure, things that the acoustic model does not include, right? And so I think there's a lot of room for phoneticians and sociophoneticians to participate in this work.
Thank you, Alicia. Very nice. So I see Patrice Johnson, you also have your hand raised. Do you want to ask your question?
Hi, thank you. I'm a first year student in for a Master of Science in Information. I've studied foreign language, but never formally linguistics. And I'm wondering if you can talk more about the skills and coursework that are the most valuable prerequisites for being able to work on this kind of research team.
I'm not sure I'm the best one to answer that because I feel like I've come in through the back door, but absolutely, you need to have an introduction to linguistics to be able to understand the units of analysis that linguists work with. The notion of the sociolinguistic variable is not one that a lot of industry specialists have. And so training in sociolinguistics, training in acoustic phonetics and perceptual phonetics, I think is really important, so that we can try to understand what's important to extract from the acoustic signal. And so in my group right now, we're sort of asking, like, why do computational linguists still work with MFCC features? Are there not better ways of thinking about decomposing the acoustic signal? And so far, the best answer I have is it's the one that was most readily applied early on. And so that's the one that they're still working with. So I think that those kinds of training that we had were great. And for me as a linguist, I wish that I actually had taken or could take, I'm trying to do some self-schooling here, but computational linguistics as well. And so I think that machine learning and speech to text are particularly important for this work.
Thank you very much for your answers to both of those questions. I appreciate it.
Okay, now I'll take, so Savi had her hand up, but put this in the Q&A, so let me read it out and then, or Savi, do you want to just, well, let me read it out. Okay, so here's Savi's question. Thanks so much for this wonderful talk and important work. I'm especially excited about rethinking hegemonic notions of native speaker. My question, I'm curious about some of the general errors, those which you didn't target ahead of time. I'm wondering if you found that some of these were distributed non-randomly across ethnicities. Do they correspond perhaps indirectly with some of the measured sociolinguistic variables, or alternatively, might you be able to use the general error data to find emergent features of ethnolex?
Oh, that's a great question. I think that there are several parts to it, and I want to maybe just start with one. I was not going to present this slide. Am I still screen sharing? Can you see this?
You are screen sharing. I don't see, and there you go. Yep.
So I think that there are a number of ways that I can answer your question, Salvi, but here's what surprised me. I think that ASR systems are really beholden to their training data sets. And so by that, I mean that there were a lot of common words that I was surprised were actually problematic for the system that are not related to any particular sociolect or emergent sociolinguistic variables. So it regularly got the word northwest wrong, returning earthless, which surprises me. It couldn't get Northwesterner either. I particularly loved Northwest Eric. It got the first person pronoun me wrong, typically replacing Maine. And so there were a number of ways in which some common forms that may not exist in Wikipedia databases where they can actually scrape some comments or video, YouTube, Google, the Globe database. Those are biasing, I think, because of the types of corpora that are being used for training and testing. In my lab, we actually call the last two tech bias errors because phrases like jobs for are going to come out as JavaScript, and a common phrase like a lot of it came out frequently as online. So in addition to the things that we think are part of the general errors that had to do with dialect-specific types of problems, I think that there's just a problem of where they're getting training data from. It's not what linguists would think. It's not field-collected data from real people. It's materials that are specifically collected for studies of human-computer interface data. And so I think that's a big part of the problem. So they're anxious to get their hands on our data sets as well, is what I can say. And the more that we can make generally available, the more that I think that helps.
Thank you, Alicia. So I think I might have scared people away by saying there were a lot of questions in the raised hand because the hands have gone down for the most part. So right now I don't have hands raised. So if anybody either wants to raise their hand or put something in the Q&A, please go ahead. I know some hands were up that are no longer up. Joseph, Tyler, okay. Ask away, Joseph.
Thank you, Pam, and thank you for a wonderful talk. And I'm thinking about the pipeline of ASR in a broader product, partly because I work on one where we leverage these for conversational interactions with the bot. And what you think the strongest impacts would be downstream for these errors and these different groups.
The strongest impacts in terms of improvements that we might make?
Sure, I mean, that would be one type, but also the types of errors that would cause failures for their ability to achieve a goal. You know, if certain types of errors are more likely to cause the task to fail, as opposed to it just being in passing.
Yeah, okay, that's a really good question. So from what I see, I think it's really interesting that although we see pretty good behavior in terms of the upstream changes that the language model is actually able to make in some cases, I think that the frequency of consonantal errors in the conversational materials is possibly the largest potential point of failure. And so I would think that it would be very useful and I'm actually working on this. This is one of the things that I mentioned in the last slide, working on trying to update some of the pronunciation model tables that are out there to include all of the consonantal variables we're actually working on right now, and a few of the vowel errors as well. So updating those dictionaries that are in use to try to incorporate some of the variables that I just mentioned that are responsible for, you know, about 26% of the materials that we have. And we're working on applying this in our own version of a transformer GT model and finding that it's helping quite a bit right away.
Awesome. as you were talking, I was also thinking about the next step of natural language understanding, where you could add sort of recognition of the variants as well. Cool, thank you.
Thanks,
Yeah,
Joe. Go ahead, Alicia, sorry.
I was just going to say I'm really excited about all of the ways that this work can be implemented. But I have to say that at some level, there's some resistance in industry to learning linguistics because it's a different field with a different set of abstractions, and it represents a pretty high learning curve. So while I'm committed to doing this, I will say that it's not simple. And it does involve a lot of kind of teaching about basic linguistics.
Thank you. Other questions? Teresa. Go ahead.
Hi, can you hear me? Yeah.
Oh,
Hello.
how good to hear your voice.
How good to hear you and see you, and what a wonderful talk. Just amazing work that you're doing. This is great. So I have a kind of basic question probably, but I'm intrigued. As we all know, African American English is not monolithic, and you did make a reference to the fact that some of the surprising results that came out was that you didn't get necessarily basilect speakers of AL, which is not surprising, but it is interesting. And so just thinking on this continuum model, I was wondering, how would you go about finding the acrolect, mesolect, basilect speakers? Because it seems like this is complicated and would bring in class, SES, different kinds of issues, and again, maybe more of a national or more regional,
Yeah.
kind of research model. So
Yep.
What are those steps to get?
What are the steps? Yes. So I will say that I am, as part of the consulting work that I'm doing with the tech company that I mentioned, actually branching out to actually gather a very large scale nationwide sample of targeted varieties of AAL, including in multilectal communities where African American language combines locally in the sociolinguistic landscape with other L1s like Caribbean Creoles and Dominican Spanish, for example, so that we can actually obtain more data, and those samples would help us to begin to also look at some of the interactions that we expect to see with socioeconomic class, urban-rural distinctions, age, and other variables as well. So very, very, great question. And that's exactly what I started doing back in September.
Well, that's wonderful to hear. And also just a quick follow-up, for each speaker, then you might also want to get some data sets in different contexts, because we all know about intradialectal code switching, right? So that in any context, an AL speaker might use more of an acrolect, but also might use mainstream English, right? There are just the whole gamut that one speaker could contain, right?
It's huge, yes. But the data collection effort that we're undertaking actually does include a register variation component, so that we hope to get some of that as well.
Great. Excellent work.
Thanks, Teresa. Thank you, Alicia. Other questions? Marlise, let me.
Thank you. Thank you so much for such an interesting talk and very impactful work. So thank you, Alicia. So the question that I have, and I'm sorry because I joined in late, because I was one of those people who came in late. I just couldn't get in. So my question relates to the error rates that you had. So there was a discrepancy between, so they went from 1.6, all the way to 6.6. And I was wondering whether besides the dialectal, features that may be responsible for the discrepancy, with respect to mergers and properties like this, whether there were other factors that you're going to, that you have on your radar to investigate to account for the huge rate between the 1.6 and the 6.6 that I saw. Thanks again, Alicia.
Sure. So are you thinking about other types of factors that might be environmental, like noise in the recording or those kinds of things, or other linguistic things?
Other linguistic things as well as social, variables. I was just wondering whether reducing, those variables to the linguistic, or rather to those properties that you saw that distinguished the different dialects from each other would be sufficient to give you the broader picture in terms of why such a discrepancy between 1.6 and 6.6.
Okay. Yes, thanks. Right. So with the materials that we have, one of the things that we thought of initially, and I have a student looking at, actually, she's working on a thesis on this right now, in the Chicano materials that you saw, one of the things that we wondered about was actually some code switching. So we think that there might actually be places where in the Washingtonian variety of English used in that community, you also find forms that are phonologically showing phonological incorporation into Spanish, although they are English forms. And so I have a student right now who's looking at whether or not we see an increase in error rates in that particular group in the conversational mirrors materials in particular, where we might actually be seeing, Spanish related inflectional forms, or I know of a number of places where my students is interested in just things like vocalic differences in words like Mexico being pronounced as Mexico or Mexico. We did see a number of errors of that kind, which we thought that the system should be able to handle. But so code switching is one, and even things like phonological incorporation is another. Mm-hmm. Place names were definitely a problem for Yakima, which is not surprising. And word medial glottal replacement was a problem, but we do think as well that there might be some interactions with prosody that might actually be important to look at as well for that community, because there might be differences in assignment of prominence at the phrase level that feel like they would be important to look at as well.
Thank you.
I guess it's me. Thanks, Faye. This is a wonderful talk. I really, really enjoyed this. I was curious about thinking about your work on updating these models. And I was wondering if you had any reflections on the privacy implications of this, so that as the language models can be more reflective of different dialectical features, whether that might potentially expose speakers of minority dialects to potential commercial applications. And if you had any aspects of that you'd like to, that you thought about.
Yeah, that's a great question. Yes, we're thinking about it. And I will say that a colleague of mine in the Department of Linguistics at UW, Emily Bender, who also is on, I'm not sure if she's still chairing, but the LSA's ethics committee and I have been looking at this together. So we've presented together on the ethical risks of automatic speech recognition, and Emily's actively working on that piece of things. Her view, if I can try to represent it, and I agree with her, is that there are ways in which we need to be careful about the protection of identity. We also, she's thinking about this also in terms of just the types of corpora that are used and making sure that speakers have the right to their own data in this context, and that they're able to share the materials that they want to share, and that we are particularly careful that we don't allow the data, because it's being submitted particularly for this type of work, to then also get co-opted by technology companies that want to do other things with it. So we know that there's bias in reading race off of materials, and that has been very harmful. And so the consent processes that we're using to do this work are very specific about limiting the kinds of applications that these data will be used for. And yet I think we can't, you know, we would like to be able to limit it on the commercial side, and are still finding that it's very difficult to get those kinds of assurances about how the data will be used once it starts to be used for these models.
Thank you so much. Yeah, I agree. Getting access seems like an important thing. And I appreciate the work that you're thinking about.
Yeah, thanks for that question, David. We're getting close to time to letting Alicia take a break and starting our reception. Any other questions? Let's see if there's anything in the Q&A. Yes, there are a couple of others, if you don't mind. Do you have it in you, Alicia, to take a couple of more?
Always.
Okay, all right. We don't want to go too long because we're already over our normal time, but we started late. Claire Bowern said, "Thank you for a fantastic talk. Do you think there are also gender differences?"
I was wondering if somebody would ask that question. You know, I think that there are, I can't answer that as well as I would like to at this point, because our numbers are not as balanced as I would like for gender. But one of the things that I will say, knowing the corpus, is that I think that there is a link between gender and social network type. And I can talk about this specifically with regard to our Yakima and Chicanic subsamples, where the speakers that we have tend to be, if you will, more sociolectal, the more insular their social networks are, regardless of their gender. And so what I can say from our materials right now is that I feel like I'm channeling Leslie Milroy, which maybe is appropriate here. But, you know, just like the Milroys found in their work in Belfast, I think that it really is social network that tells more of the story than gender does in this case, because it's tied to whether everybody in somebody's close friend network was from the same locale, or whether their networks were actually tied to other communities as well. And that falls out along gender lines.
Thanks, Alicia. Okay, another question. This one from Hadas Kotek. Thank you for this wonderful talk. I wonder if you have thoughts about how to begin to scale this type of work up into other languages, regions, dialects, since virtual assistants and ASR services target many markets, not just the US one. It would be really great if we could get tech companies to think about dialectal variation beyond American English.
Yeah, I do have ideas about this, but I hadn't thought about this in advance. So for those of you who are interested in trying out clocks, it actually accomplishes transcription not just for American English, but think that there are something like 8 different languages that it will actually transcribe. And in our department, we have people working on several of those. And so Microsoft Speech claims to have ASR system pronunciation and language models that work within Arabic for 4 different varieties of Arabic, within Spanish for 6 different dialects of Spanish. And so I've been trying to ask my students to put that to the test and to actually see, for varieties that they have sociolinguistic knowledge of, how well Clocks performs looking at those other languages. So I have a student working on Polish and another one working on Spanish right now. So I think that this model that we're using could scale up pretty well to work with other languages, so long as there's good sociolinguistic information that can support the error analysis and the categorization initially of forms into types. So go to the website and check it out if you like, and then see what different dialects are actually in the drop-down menu where you choose language. Then I think it can be tested from there.
Okay, last question. This one's kind of a tough one. Not that the other ones weren't, but this one is, thanks for a wonderful talk, and then asks a question about prosody. And asks, how well do you think speech recognition systems deal with this type aspect of language, if any? I would also appreciate some advice on readings or tools you might know of. Thank you.
Okay, I'm not sure what types of readings or tools the question asker is referring to. So if that could be clarified, that would be helpful for me. I can't actually say a lot about prosody at this point. I'm sorry to be able to be disappointing in that regard, but we haven't really been able to look at that. So one of the things that I can say, I think one of the things that you get when you use an MFCC approach is that it strips out F0. That's kind of the point. One of the things that I was kind of shocked by when I started looking at these models is that pitch information is viewed as being unimportant. And so pretty much all of the readings that I have been able to take in make the point that this is shocking. Like I write in the margin of these articles, but pitch is not important, and they think that specifying the acoustic characteristics of phones is also simple. And so I think that there's really a misunderstanding there when it comes to the potential role of prosody. And just in understanding the kinds of phonetic phenomena that are sort of connected to that. And I would say co-articulatory patterns. I'm sorry, my family's coming in the door and I'm hearing voices. But yeah, I think that there's a lot yet to be gained by really asking what the optimal representation of the acoustics should be, and whether we're missing quite a lot by thinking that we can specify formant structure in the absence of any other type of information. And I may be misunderstanding how certain models for other tech companies work, but as far as I understand it, that's the way that things currently work.
Thanks, Alicia. So the questioner did follow up, but I think you pretty much answered this, but said in response to your question about any more information about what tools they have in mind, the response was tools in ASR that take prosody into consideration, but you've sort of already addressed that by saying they kind of ignore these things. Okay, I think this is a good point at which to segue to thank Alicia again for this wonderful talk. And there are thank yous happening in the chat and claps happening and so on. And we're also going to now go into, Alicia's agreed very graciously to go into reception with us for a little bit. And so the link to the reception is in the chat. So we're going to end this and go into that link. So I hope thank you all for joining us. Thank you again, Alicia.
Thank you.
And those of you who have the time, I hope you can join us in the reception in just a moment. Bye-bye.